Hi guys, today's lesson will be on solving conditional trig equations using the quadratic formula. And this can get a little bit convoluted, so just make sure you're paying attention to each example, and you'll definitely need your calculators for this lesson, so make sure you have that handy. And I'm also going to show you guys how to check your answers in the calculator so that you don't have to always do it by hand, because it's rather easy. But remember, my calculator doesn't pop up on the screen, so you'll just have to sort of follow along as I voice the instructions. So over here, remember I have written out what the quadratic formula is, right? Just so you know that that's what we're going to be using for these examples. Obviously, if the problem is presented to you as a quadratic, I would try factoring normally first, but if normal factoring doesn't work, just know that we can use the quadratic formula. So for example, number 1, we have sine squared x plus 3 sine x minus 3 equals 0. And this is a quadratic that cannot be factored normally, so I would list out what our a, b, and C components are, and remember those are just the coefficients in front of the squared, the sine x, and then the constant respectively. So that's 1, 3, and negative 3. And then in the normal quadratic formula, it's always set equal to just x, because normally our quadratics are of the form ax squared plus bx plus c equals 0. However, here we have sine squared x plus 3 sine x minus 3 equals 0. So when we go to do the quadratic formula, this is actually going to be a trig function over here, whichever trig function you're working in terms of. So in this case, we're going to have sine x, and then I'm just going to apply the quadratic formula. So it'll be negative 3 plus or minus the square root of 9 minus 4 times 1 times negative 3, all divided by 2 times 1, right? So we solve that out first. So you get negative 3 plus or minus the square root of, it turns into 9 plus 12 because of that double negative there, all over 2, which is negative 3 plus or minus the square root of 21 over 2. Okay, and so remember, what we're actually dealing with here are two different equations. So what I would have you guys do next is split the function up into the two equations. So one of them will say sine x equals negative 3 plus, root 21 all over 2. And then sine x equals negative 3 minus root 21 all over 2. Okay, so here's where we're going to go into the calculator. So the first thing I would have you do is actually evaluate what these decimals are, right? So I'm going to go into the calculator, and just in like the regular screen, I'm going to type in negative 3 plus the square root of 21, and I'm going to divide that number by 2, and I got like 0.791-ish, right? Now remember, you don't want to truncate that decimal whatsoever because we won't round our answers until the very end. But by getting approximately 0.791, what that's telling us is, number one, the fact that this is a positive ratio. So again, if I do a smart trig class, I know I'm in quad 1 and quad 2 because that's where sine is positive. And now I have to actually solve for x, which means I would inverse sine both of these sides of the equation. So I don't know why that didn't change color, but I'm going to inverse sine this side so that those guys will cancel. And I'm going to inverse sine this entire decimal, okay, so that I get the exact answer there. So when I do that in my calculator, you can just hit second sine, that'll give you the inverse sine, and then second, and then the negative key will just plug in the previous decimal as answer, and then hit enter, and you should get 0.913 if we round to 3 decimal places, right? So my answer there for x is 0.913. That would be our answer in quad 1, But remember, we also want that same answer in quad 2. So to do that in quad 2, just like we would with any angle, we're going to do x minus this exact decimal. Not the truncated decimal, but the exact decimal. So, not x minus, excuse me, I meant pi minus. So second pi minus second negative for the previous answer, and then you should get 2.229 for the second quadrant. So 2.229 would be our answer in quad 2. Okay, now we do the same thing on the other side. So that again, the first step is to evaluate what this is. So I'm going to go back into my calculator in the normal screen, and I'm going to do -3 minus the square root of 21 this time, and then divide that by the 2. And that should give you approximately -3.791. So that is approximately -3.791. But again, as you might be aware, right, sign has to be in between -1 and +1. So right here, I can stop my problem. I know I'm not going to yield any answers there. So in fact, these two would be my only two answers for this one problem. Now, technically, with this particular trig function, you do not have to check your work because everything in the original problems in terms of sign, there's no denominators there. We didn't use the strategy where we square both sides of the equation to give us extraneous solutions. So we can be confident that those answers are good to go and we don't have to check anything. Okay? However, if you wanted to check, here's what you would do. So I'm presenting this as a separate option. You can really do this with any problem that I've given you so far. You're going to go into your calculators, and on paper, whatever your equation is, you're always going to set it equal to 0, okay? So here, what we would do is we're going to now go into the y1 screen. We're going to hit parentheses, sine x, and then close the parentheses twice and square that quantity, and then plus 3 sine of x, close the parentheses on the x, and then minus 3, okay? And you're going to go into the graph, sorry, not the graph, you're going to go into the table, so you hit second graph to get to the table. And again, if you have any values in there, you can delete them out. And I'm going to type in what we got for x into the x column, which is 0.913. Now remember, we rounded that decimal, so I'm not going to get 0 exactly in the y1 column, but I'm going to get a decimal that's close to 0. So when I hit enter, I get a number that says 2.5 e to the -4. Remember, if you get any type of number like that where it's like e to the negative something, it means you're moving the decimal point over to the left that many spaces. So we're going to take numbers like that as if it were 0. So 0.913 definitely works as an answer. I'll do the same thing with 2.229. And I get -9e to the -4. So again, that's a number close to 0, and so that's how I know they both work. If I get a number like 1.579, something like that, then that we consider that far from 0, and we would reject that answer in that case. Okay, so let's go ahead and try another example using the quadratic formula. Here's example 2. So 2 tan squared x minus tan x minus 5. Again, if this was in a pool of problems, I would definitely try normal factoring first, but if it doesn't work, then we have to use quadratic formula. So here A would be 2, B would be -1, and C would be -5. And this time we're going to have that tan x, because that's the trig function we're working with here, equals, and then we plug in. So 1 plus or minus 1 square root of 1 minus 4 times 2 times -5, all divided by 2 times 2. Okay, so that gives us 1 plus or minus the square root of 1 plus, is that 40 all over 4? So 1 plus or minus the square root of 41, all divided by 4. Again, these are two different equations, so we want to split them up. So I'm going to go ahead and do that. So we get that tan x equals 1 plus root 41 all over 4, and tan x equals 1 minus root 41 all divided by 4. Okay, now I think by inspection we can kind of tell that 1 plus root 41 all divided by 4, that's going to be a positive ratio. So when we go to do a smart trig class, we know we have to be in quads 1 and 3 for tangent. Moreover, if you guys remember, the boundaries for tangent were all reals, so I don't really have to figure out this exact number to determine if I'm allowed to solve for x or not. Because my trig function is tan, I know I will be allowed to solve for x, since tan can be any number it wants to be. So I'm going to go into my calculator again, and I'm going to type in to the regular screen 1 plus the square root of 41 all divided by 4. Okay, and I get a decimal of 1.8507, right? But remember, I need to inverse tan that decimal in order to solve for x. So I'm going to hit second tan and then second negative to pop that answer in. And the angle in the first quadrant that you should get is approximately 1.075. So that's one of my answers because I know I landed in quad 1. So x equals 1.075, okay? And then we're in quad 3. So whatever I got for this entire decimal, in quad 3, we always have to add pi to it. So I'm going to go ahead and do that in my calculator. I'm going to hit second negative to take the previous answer. I'm just going to add pi to it. You can also store these things as x and use that strategy as well. So in quad 3, you should get 4.217. So x equals 4.217. So this is quad 3. This was quad 1. Okay. All right. And now we have to do the same thing for 1 minus root 41 all over 4. So again, I'm going to go to my calculator. I'm going to enter in 1 minus the square root of 41 divided by 4. It gives me approximately negative 1.351. Okay, so because that number is negative, again, you got to be careful here because that simply tells us, right, if we do a smart trig class, that we have to be in quads 2 and 4. But remember what I said, you want to drop the negative. You don't ever want to take the negative. So I'm just going to take that number of negative 1.35 blah, 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 and multiply it by negative 1 so that it becomes positive. Then I will inverse tan that to solve for x. So my x, which would land in quad 1, would be approximately 0.9335. Okay, but that's my angle in quad 1. I know I'm not in quad 1. I'm in quads 2 and 4. So I'm going to take that 0.9335 decimal and I'm going to store it as x because I want that same angle but in quad 2. So I have to do pi minus my stored x now. That gives me 2.208. So always be mindful of what quadrant you're working in, just so you get the correct answer. So here we get x equals 2.208. That was quad 2. And then we got to do 2 pi minus our stored x to get where we are in quad 4. And that should give you 5.350. So 5.350, that's your answer in quad 4. Okay, so that was definitely way complicated, but you know, you can go back and rewind if there's any part of it that you missed. Again, you guys are welcome to try checking these answers in the table form, like I showed you in example 1. This would be an example of a problem where you don't have to check because, again, the original is in terms of all tan, so we know that we're not getting zeros because we're getting whatever this decimal is at those angle measures, so we're good there. Okay, let's move on to a few that don't require the quadratic formula, just as like review. Because I know some of you guys were like struggling with some of the ones that were, you know, maybe a little bit different. A lot of people were asking questions about something like this, where you have one trig function in terms of tan and the other one in terms of cotan. Some of you guys were converting everything to sine and cosine, and that's fine. You could totally do that. What I would recommend doing for an example like this is I would make this tan x and then just make this 3 divided by tan x, because we know that cotan is really 1 over tan, and then minus 4 equals 0. And then I would approach it by multiply everything by tan x, so I clear the fraction. So that gives me tan squared x plus 3 minus 4 tan x equals 0. And then again, this turns into a quadratic, so I have to get it in standard form. So I'll write that out. And then I'll decide, can I factor this normally, or do I have to use quadratic formula? Now, luckily for us in this case, we can factor it normally, so that's good. You get tan x minus 3 and tan x minus 1 equals 0, which means tan x has to equal 3 and tan x has to equal 1 here. So 3 is a positive ratio, so if we do a smart trig class, we know we're in quads 1 and 3. And now I'm going to use my calculator to inverse tan 3. So, because that's not a recognizable ratio for me. So second inverse tan of 3 in quad 1 should give me 1.249. So x equals 1.249. That's in quad 1. And then I'm just going to add pi to that to get my answer in quad 3, which should give us 4.391. And that's your answer in quad 3 over there, okay? Over here, tan x equals 1, I could do that by hand. Again, establish where you are. Tan is positive again, so you have to be in quads 1 and 3. And I know that when my ratio is 1 for tan, that means it's my 45, 45, 90 triangle. So my reference angle is pi over 4. So in quad 1, that's pi over 4. And in quad 3, I have to add pi to it, so that gives us 5 pi over 4. Okay. And again, the only thing I would be wary of, again, you can use your calculators to check this by plugging these numbers into the into the table, and then seeing if you get 0 in the y1 column. And because there's no cotan button in the calculator, I would literally enter this second step into your y1. Just make sure the 3 over tan x is in parentheses, and then you should get that actually all of these answers work. Okay. All right, one last example is sine x cosine x equals 1/4. Again, there's a couple different ways that we can consider how to do this, but I think the easiest way to do this is to recognize that this is a manipulated formula for the double angle identity for sine. And so in order to get it to be the exact identity, what I would want to do is multiply this by 2. But what I do to the left, I have to do to the right. So I'm going to do that. So I get 2 sine x cosine x equals 2 times the fourth is 1/2. And then I can turn this into its identity, which we know is sine of 2x equals 1/2. And then kind of going back to like day 2 notes, right? I'm going to let a equal 2x. So I just have to solve for sine of a equaling 1/2. So because it's a positive ratio, when I go to do a smart trig class, I know I'm in quads 1 and 2. 1/2, that reminds me of my 30, 60, 90 triangle, so I'm going to draw that up. And sine of which of these angles gives you 1/2? Well, it's opposite over hypotenuse, so opposite over hypotenuse, that's 30 degrees, or pi over 6. So A in quad 1 is pi over 6, and in quad 2 is going to be pi minus pi over 6, which is 5 pi over 6. But remember, A was 2x, which means there's 2 rotations. This is only the first rotation. So to get the second rotation, I have to add 2 pi to each of those answers. So 12 pi over 6, which is 2 pi, plus 1 pi over 6 gives me 13 pi over 6. And 12 pi over 6 plus 5 pi over 6 gives me 17 pi over 6. And all of that is equal to 2x. So I'm going to multiply everything by 1/2 to get what x is. So it should be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And because my original was in terms of sine and cosine, I'm good. I don't have any denominators. So all of these answers will work. Okay? So I hope that was, kind of a good combination of problems to show you how to use quadratic formula and to kind of review some harder concepts from maybe the previous homework. But give those a try and see how you guys do for the part 4 homework for Friday. Okay, have a great day. Bye-bye.